Hello, good evening. Welcome everybody to the Sigma meeting for the month of July 2021. I'm Pete Sherman. I'm the chairman of Sigma, and I'll be. So I'd like to start off by welcoming not just the Sigma members, but also our affiliated club and society members. That'll be Aberdeen Astronomical Society, Highlands Astronomical Society, Caithness and Cairngorm Astronomical Groups, and North Ronaldsea. If you're here, you're very welcome, and it would be really nice to see you. Also, a special welcome to any guest visitors that we might have. I know a few people have come in asking if they can come to the meeting, and if you're here, you are more than welcome. And if you feel like joining at the end of this, contact Mick and he'll let you have all the details of how to do that. Put some light on here. There we go. I'll be your MC for the evening. Helping me in the background is Rich and Mick, who are the Zoom co-hosts. You won't see much of them, apart from them bits they're going to be doing, unless something goes terribly wrong technically on my end here, and then they'll jump in and take over. Also in tonight, we've got Stuart Brooks, who will be giving us the space news in the second half, along with Mick, who's going to be doing the members' photos tonight. And we got quite a few of them come in because there was a good display of the Northern Lights, the non-inclusion clouds the other night. Just before I start, I would like to say something about the Scottish Dark Sky Observatory. You'll remember that in July 2020, the meeting now, we had David Warrington, who gave us a wonderful talk about the observatory. What you may or may not know, as I've heard about, is that on June 23rd, there was a devastating, suspicious fire at the observatory, which has totally destroyed the facility. All that's left standing basically is the pillar for the telescope, which is very, very sad news. The Deep Sky Observatory have set up a funding page. If you'd like, if you've got a few spare coins, please pop it over to them over there. They're going to need all the help they can get to get it rebuilt, and hopefully it won't take many years to get it done, and then we can go and go on that trip down to there that we planned to do last year. Okay, I'll put the link to the funding page in the chat in a little while, but just search for Scottish Dark Sky Observatory.co.uk and you'll get on there anyway. Okay, so as I say, we got a couple of new members here, I believe, or visitors. So I'm just going to go through a little bit of the Zoom controls you've got in your toolbar, your Zoom control toolbar. By rolling your mouse over the screen, that'll pop up. If you have any questions for our speakers tonight, just pop them into the Q&A. You can do this anytime throughout the talk. You haven't got to wait until the end. They'll just stay there, and Rich will pick them up at the end and ask them over to Ian. Don't put your questions in the chat, because the chat can move on quite quickly and they'll get lost in there, and it's hard enough for Rich to keep an eye on the questions in the Q&A, let alone in the chat as well. You'll notice we've got closed captions working, and now if you don't want them on, you can turn them off by the closed caption, so the live transcript button, I think it says. If you click that, you can choose to turn them off there. Okay. There also, you will see a little raise hand button. The chat does get turned off during the speaker's presentation because it can be a little bit disorientating to keep getting these messages popping up. But if you have any issues at all, just click the raise hand button, and then we'll notice that you got your hand up, and one of us here on the panel will contact you through the chat privately, and we'll see what we can do to sort things out for you. So say, don't forget your questions. The more questions, the better. Just pop them in the Q&A anytime you want to. At this point, I'd ask any panelists that's here, I meant to say earlier on, to make sure your mobile phones are on silent and your telephones are off the hook, so they don't ring in the middle of Ian's talk he's going to give to us. And just before we go on to that, just remember that we've got the gathering coming up after this. Everybody's welcome. As I say, the members gathering, the Sigma gathering. I'm calling it a Sigma gathering now. It's not just for members; it's for everybody. We've run a few of these in these meetings, and it's a great fun way. We all get together, have a chat, meet up, because we're not doing that sort of physically at the moment, and it's a nice way to keep the social side of Sigma going, which is a very, very important part of Sigma. Everybody's welcome. So, and speakers, guests, first-time visitors. Just, I'll tell you more about how you get into it later on in the second half, but everybody's welcome to that. Okay, the meeting brief. We'll have a main talk from Ian Morison, Professor Ian Morison. Rich will then do the Q&As. We will then have our 10-minute break where the chat will go back on and you can have a chat with everybody in the room and do it that way, and keep in touch with your friends. After that, Mick will be doing the members' photographs. Then we'll have Stuart doing his space news. And to end the night off, I'll be doing a little bit of club news, and that'll be us finishing around about 9:30, something like that. We're not sticklers for time here. We'll just go on until we finish. So anyway, tonight we're going to be taking a look at the wonders of the southern skies with Professor Ian Morison. It gives me the greatest pleasure to welcome back to Sigma, albeit remotely this time. And it is a shame that we couldn't host him once again like we did back in 2011. Yes, it was 2011. That was the last time when he was up. You might remember Ian came up and not only gave a talk for Sigma, but he also gave a talk, and that was on Friday night. He also done a joint talk with Sigma Has, and I believe Keith Ness was there as well. That was over in there, and on the Saturday night. I think he actually ended up doing 3 talks on that weekend to make his journey this far north worthwhile doing, I think. Ian is an astronomer and an astrophysicist who served as the 35th Gresham Professor of Astronomy. Though a radio astronomer by profession, now in his 56th year at Jodrell Bank, the Jodrell Bank Observatory at the University of Manchester. He has been a keen amateur astronomer since making his first telescope with lenses given to him by an optician when he was about 11 or 12. In 1990, he became the founding member. He helped found the Macclesfield Astronomy Society, of which he is now a patron. And he is a past and present of the UK's Society for Popular Astronomy. Now acting as an instrument and imaging advisor, he writes regularly in telescope. And he writes a regular telescope topics column for the Popular Astronomer, and he has made many contributions to the Sky at Night and Astronomy Now magazines. Ian is a well-known author, having many books published, Observing and Imaging the Heavens, A Journey Through the Universe, and The Art of Astrophotography, to name just 3. He also writes a monthly sky guide, which is available free to anybody via the University of Manchester website, a link of which is now on the Sigma website in the this month's sky guide section. So without further ado, I would like everyone, please, would you welcome Ian Morison all the way up from Lancashire. Ian, over to you.
Thank you very much, everybody. And it's a pleasure to be back with you. And I fondly remember my trip now 10 years ago. I remember someone, I think, from your society was involved with the Strathspey Railway and gave me a free ticket. I had a lovely trip on that.
That was right. Yes, it was. Yeah. It
was. Anyway, it's lovely to be back with you. And hopefully you'll enjoy the talk. So let me try and share my screen. And I want to make sure the share sound works. And I want to click on that. Can someone say?
Yep, we can see that, Ian. Yep.
That's okay, very good.
Over to you.
Well, it's a slightly hyped title, this. You have to have a short title, I think. I don't really like hype. So in fact, what it should really be called is this: Objects in the Southern Sky You Might Find a Bit Interesting. And I hope you will. There's a certain amount of astrophotography in it. You mentioned I've written at least one and a half books about this. And there's an awful lot on my Astronomy Digest website about astroimaging, but not too much. And essentially, I should be using some wide field images I've taken just to show you the parts of the sky we're going to find hopefully interesting objects. So it's partly illustrated with some wide field pictures of the Milky Way. Now, it's actually a very hard thing to do to image the Milky Way because you can't really get rid of light pollution. You need very dark skies. And one place I've been able to be reasonably successful is here, not in the UK, but in Ireland, in one of the 4 gold tier dark sky sites. This is in Kerry, which is the very southwest of Ireland. There it is, right down the bottom here, very close to the Skelligs. And those what is into these things might be aware that they were in A Force Awakens and The Last Jedi. I can't claim to be an expert on these, but you might have seen it. And essentially, I went to a star party just about where my arrow is. This is one of the darkest places you could imagine in northwestern Europe because you're just looking out over the Atlantic, and there's very few people live anywhere locally at all. The instrument I was using was a device called an AstroTrack. And essentially, if you want to take long exposures of the sky, even with a camera lens, you need to sort of track the stars, otherwise you get trails. And this, though it's no longer made, was one of the very best you could buy a few years ago. Essentially, at the bottom there, this arm is called a tangent arm, gradually moves sideways, rotating the axis here to keep step with the Earth's rotation, to compensate for it. In fact, it's very accurate because the effective diameter of the gear that's doing it is twice this radius. So it's a very large gear ratio, and that means the tracking is very, very good. It is, however, fairly large, not something I could take to the southern hemisphere. This was the first picture I took there. We only had about an hour and a half of darkness, but as I was taking it, two guys came up and said, "Is your picture green?" So I looked at it, and there it is. "Yes," I said. They said, "That's good because we're using a Canon camera and you're using Nikon or Nikon. So what is it?" I had never seen this before, and some of you may well know what it is. It's called airglow, skyglow. I'm sorry, skyglow. No, airglow. Forgive me. And that green color is the same color that you get in the aurora borealis. It's the oxygen line. So you only ever see it under very dark sky conditions. It's caused by ultraviolet light, I think, from the sun exciting atoms in the daytime, and they cascade down at night and give you that lovely green glow. And that's a picture, in fact, air glow taken from the space station. And it's actually one thing that makes the Hubble telescope better than those on the ground, because it's about 50 kilometers high. Nothing on the ground, even on the top of Mauna Kea, can avoid it. And it does actually limit what you can see. And the Hubble telescope obviously is much above that. Though sadly, I saw today that it's had some real problems. And after 3 weeks, they've yet to sort it out with one of their computers. But let's hope they can do so. And so that was the final picture I took. It's actually a vertical panorama, 3 horizontal bands put together. And I haven't quite got rid of the green at the bottom. This is Delphinus the dolphin. I do love that little constellation there. Over here, we've actually got Vega, and up here, that's Deneb and Sadir, and this is Cygnus, and that's obviously Lyra over here. And this is called the Cygnus Rift, which is a rather dark region. And there's a very nice asterism. That's here, there, and there. That forms the summer triangle. And if you come up here to where the Cygnus Rift is, there's a lovely little asterism, which is actually called Brockie's Cluster, or the coat hanger. Anyway, this is all about the southern hemisphere. And my son married a Kiwi, which is not a bird, but a girl from New Zealand. And they emigrated there about 12 years ago. And I've been going out there for a while. And as part of my sort of tripping around the world occasionally to conferences, I became a friend of a person who was in fact the superintendent of the largest observatory in New Zealand at Mount John at Lake Tekapo. And I've stayed with him several times. And on 2 of those occasions, it's been clear, and I've been able to take some photographs, as you will see. So you can see Christchurch on that map on the left. As you go down to here, we come to the Araaki Mackenzie Dark Sky Reserve. And that is also one of the world's 4 gold tier dark sky sites. And the Mount John Observatory is in that, just beside Lake Tekapo, about where my pointer is there. So on every trip we've ever been to stay with my son, who actually lives a little south of Christchurch, we've always been there, and I've always visited the observatory and tried to do some astrophotography when it was clear. That's Lake Tekapo, not my picture. I wish it was, but there's the Milky Way. This actually is the Large Magellanic Cloud. It's becoming quite famous. There's 1 or 2 other spots down here for what they call astrotourism. As you'll see, I went there last in February 2019, and I've just zoomed in on this little bit here, and you might just see a couple of domes. Those are 2 of the telescopes. The largest is a 2-meter telescope at the Mount John Observatory. So as I said, astrotourism is taking off down there, and this is a place, they call it Tekapo stargazing, where they've got some hot springs, and apparently you can go and lie on lilos in a hot tub, basically, and look up at the stars. I haven't done it, but I wish I could, perhaps sometime in the future. So that setup I took to Kerry, and that was also using a fairly heavy full-frame Nikon DSLR, a very good one, was too heavy really to take to New Zealand. Anything that's valuable I wanted to have in my backpack. So I bought a lightweight camera, and the first one I bought was one of these so-called Micro Four Thirds cameras. They have a sensor which is about half the size of a full frame, but they were then about the smallest cameras with interchangeable lenses, and I did buy an exceedingly good wide-angle lens for it. But I also bought a very lightweight tracker. It's called the Nano Tracker, which I suppose implies it's small. It actually came from Australia because the cost was a lot less than there. This is the tracking bit up here, and very nicely, the power and the control comes from this unit with simply 3 AA batteries. So it's a very small, easy thing to take with you. It's not actually quite heavy. It can't, of course, take very, very heavy cameras, but the types I've been taking there have been fine. And again, that's mounted on a lightweight tripod that will go in my case. So that's what I was using. And about 6 years ago, I was able to take a picture of the galactic center from the Mount John Observatory. Looking back on it, it's not all that good, but I was quite pleased with it at the time. Now it's upside down, so you won't actually make an awful lot of that. But let me put in some little lines to show you the constellations. Here, of course, is Sagittarius, the teapot. This is Scorpius. We'll talk about those a little bit shortly. And rather nicely, around here, this little circle of stars is called Corona Australis, the southern crown. If you imagine tea coming out of a teapot, sort of coming out here, it actually passes through one of the open clusters in Messier's catalogue, M7, and there's another one called M6, not quite so close to the, well, actually it's in front of a dark dust cloud, so you don't see so many stars. We'll see those shortly. In 2018, I bought myself an APS-C camera, which has a rather wider field of view, a rather larger sensor, and it's an exceedingly good one for astrophotography, because can you see that that actual screen tilts right the way around? Now, from, as we'll see, well, from New Zealand, the Milky Way goes directly overhead. And that first time when I had the little Panasonic, I was literally having to lie on the ground with my head looking up at the screen to try and see where on earth I was looking. But with this one, there's no problem at all. And I've used that the last 2 times, in fact, that I've been to New Zealand. And there it is, again on the Nano Tracker. Quite a nice thing is that I've made a little mount here, and I can fit in a small ice pack to help keep it cool. Because the one thing these things don't have that proper imaging cameras have, astral imaging cameras, is they don't have cooling systems. That helps keep the noise down. And the great thing about these little APS-C or mirrorless cameras is that you can actually have adapters to use many, many what are called legacy lenses. And I've got some lovely lenses. You'll see a result of using a Zeiss 45mm lens a little bit later on. So that's what I've taken the last couple of goes I've been there. And for this particular trip, I bought a special lens, a very wide angle 12mm lens, so I could get nice panoramic views of the Milky Way, as you'll see. It's quite a complex lens, and it's fully manual, but it works very well. And I'm just going to show you the first pictures I took. My son lives in Lincoln, which is south of Christchurch. Now, when I actually first went there, when he lived there, he bought his house there, he was right on the edge of the town. But in fact, you may know there was a rather nasty earthquake at Christchurch, and the land to the south, which is where he's been living, is much better, apparently, than the land to the north. So there's been quite a shift of people from central and north Christchurch to further south. And in this picture, you can actually see where this was all fields, there's now lots of houses. And I really show this, it's a wide angle picture with that lens, but can you see the lamps? So they're not fully shielded. So there is now light pollution. However, I have been there, and I remember one morning I went out at about 5 o'clock, the little play park just over to the right here actually, and I sat behind the wall to take the pictures you're about to see, and I scared the living daylights out of a lady walking her dog at about 5:45. I don't know whether she's recovered or not, I don't know. But that is the panorama I took of the center of the Milky Way, and I'm really quite pleased with that. There's a couple of interlopers. The bright star you can see here is Antares in Scorpius, which is around here. Sagittarius is down here, but the two interlopers, the brightest object there is Jupiter, and down here is Saturn. And you'll know, of course, that at the moment, and in the last year or so, in fact, they've been right at the lowest part of the ecliptic. So I'm afraid from where I live, and even worse from where you live, they're at fairly low elevation, and so our imaging and our view is not quite as good as it might be. So that's the central part, and over here we're coming to a next strip that I'm going to show you later on. Anyway, I've just put in some lines to show you the constellations there, Sagittarius and Scorpius, along with Jupiter and Saturn. This, in fact, I think is called the Sagittarius star field. So I know we can see Sagittarius and Scorpius from our northern climes, but I don't see it very well. So I'm going to start with a few pictures and something about Sagittarius. There are two lovely nebulae there, the Trifid or Trifid and Lagoon nebulae, you see there together, not too far away. There they are, and you can see perhaps here, there we have the bit of the splitting up into three, hence the name Trifid or Trifid. This, by the way, and this is H-alpha emission for those that might not know. Ultraviolet light from very bright stars, some of them would be about there and some there, excite the hydrogen, and electrons in fact are split off, and as they cascade down, one of the transitions gives rise to the H-alpha emission line, and that's what you're seeing in these pictures. But you're also seeing this blue emission, and that's in fact called, it's a reflection nebula, and what's happening here is that the bluish light from probably that star there is being scattered by dust. So these are the two colors we tend to get, the H-alpha emission nebula and the reflection nebula, as we see there. And that's just showing quite nicely the center of the Trifid nebula with the dust lanes here, and looks like a multiple star system in the center. And there's the Lagoon nebula, again another lovely region in the southern sky, and you can photograph that from where I have to say I've never actually done it. I don't have a very good southern horizon from my home. And something I actually first saw in Hawaii, I was there for a conference, and a friend took me out to where he had his 12-inch telescope, and I think you can actually see it looks a little bit like a swan, M17. One I'm sure you know of Messier's. There are now about 110 objects in his catalogue, and he didn't actually discover them all, but he made this very good catalogue of some of the best objects that we can see in the sky. And it's also called the Omega Nebula. I like swan. This is interesting, I think. We now know that essentially all galaxies have got black holes, massive, supermassive black holes at their heart, and we have one in our own Milky Way galaxy. This is to show you how we found out, how it was found out, how massive it is. You can't see it visually, there's too much dust there. You can in the X-ray, the little arrow there pointing to it nominally. The VLT, the Very Large Telescope, that's part of the European Southern Observatory, which is on the Atacama Desert in Chile. And happily, ESO, the European Southern Observatory, is not part of the EU. We're still members of that and have access to these 4 8-meter telescopes there. Anyway, that's a picture of it there. Now, the great thing is that we now have the use of what's called adaptive optics on these giant telescopes. If you had a star very close to the object you're trying to image, you know that star is a point source. You know it should have a flat wavefront. However, of course, the atmosphere distorts it. And by measuring that distortion, you can then have a tertiary mirror with lots of little piezoelectric actuators behind it to actually meld that mirror to an inverse shape of what the atmosphere is doing, and hence calculate, hence eliminate the atmospheric turbulence effects. Now, you don't normally find a star where you want it, so they make an artificial star. They have a laser sending up a laser beam in sodium. It's a sodium laser beam, and that forms an artificial star very close to where you want to observe. And that's been done. This is a VLT telescope. It's also been done on Mauna Kea. And these are the two Keck telescopes up on Mauna Kea. I have been lucky enough to visit those once and totally lost my spatial awareness. I was on a platform, the Naismith platform, I think, at the side of one of these telescopes, and I thought I could walk across the mirror, which was about 15 feet below me. So that was my only real problem there. I did survive otherwise. Now, this is the point. If I take pictures with my, I've got up to 12 inches of telescope aperture on my, not really observatory, my mount is outside in the open, well covered up, but that's not a bad way to do it. Now, basically, the best resolution one can get without playing tricks is about a couple of arc seconds. I've done lucky imaging of the moon, and I've got about 0.8, 0.7 arc seconds resolution. But you see, that's the size of this box here. So anything here would be one blob. But look, using this adaptive optics, they can see lots of individual stars surrounding the region where we think the black hole is. And this is rather lovely. It's a while back now, but nothing really new has happened. This is plotting the nearby stars as they move around the black hole over a period of time. It's going to keep on repeating. Notice that SO2, this one here, does almost a complete orbit. It's the yellow one. There we are. And of course, it's now done more than a complete orbit. And then also look at SO16, this one. It comes in from quite a long way on a very elliptical trajectory, and it zips around in the same way as a comet. As it goes around the sun, it goes very fast because its potential gravitational energy is converted to kinetic energy. It speeds up. And if my memory is right, that is passing around the galaxy, around the black hole region at around 12,000 kilometers per second. And I think that's the fastest velocity we know of in our Milky Way galaxy. Anyway, that's a sort of a plot. And from all those motions, you can calculate what the mass of the star is. This is the Keck telescope observations. And it's essentially 4.1 million solar masses. As I said, SO16 comes within 45 AU of the galactic center, 12,000 kilometers per second. SO2 orbits with a period of 15.78 years. That's a rather lovely bit of physics, isn't it? Using the latest and superb techniques that we have. Okay, let's move on to Scorpius. And again, I don't see that terribly well, certainly the lower half from where I live, but I can see Antares and this little nice little bit here. That's M6, and that's one of the clusters I said that you could see close to Sagittarius, but it's actually in Scorpius. And that's against a bit of a dark region of the Milky Way, lots of dust, so there are not many stars there. But M7, the other one, can you see? You barely see the stars against this fantastic spread. I mean, I don't know how many stars are in that image, but it must be an awful lot. So that's what it's like when you look right towards the center of our Milky Way. There's a rather nice feature in Scorpius, which we call the northern jewel box, which is this little cluster here. However, if you look at this with your unaided eye, I used to say naked, but the Americans reckon that's politically incorrect. I've got one American book which actually uses the word naked halfway through and changed it to unaided. And in fact, in my recent books, I've used unaided. I don't really know why. Anyway, it looks a bit like a comet. So it's sometimes called the false comet. Can you imagine? Here's the nucleus and here's the tail. So there we have, that's one picture of it there. And I think there's another one. No, that's it. Sorry, let's go back. Again, you can see the spikes there. That tells you the diffraction spikes taken when you're using a Newtonian type telescope. However, because they look pretty, a lot of people who are using refractors, which don't give rise to them, actually add them in their post-processing. But I don't know whether that was done or not. So that's the northern jewel box. We're going to see the southern jewel box a bit later on. M80. Now, this is a globular cluster. It's a classic one. The best we have in our northern hemisphere is M13. I got a reasonable image of that quite recently. They date pretty much from the time that our galaxy was formed. There might be several 100,000 stars there, and they're mostly whole, but you can see there are some red giants in there which tend to look orange. And this has got a fairly compact core here, and it spreads out quite wide. So that's a very classic globular cluster. I think there are 27,000 of them orbiting our galaxy. They're actually in a sphere, and it was Howard Shapley that measured their distances by observing Cepheid variables. We'll come to those later. And he showed that there was a spherical distribution, and we were well outside it. And the obvious correct assumption was that the heart of the center of that spherical distribution was the center of the galaxy. So from that, he was able to show that our own sun, our own solar system, was around 25,000 light years from the center. And the whole galaxy is something like about 100,000 light years across. So I took another picture. This was a little bit later on, and the sky had moved over. This is obviously a multi-way panorama. This was the first image, part of, and then this is the second. And this part here, I think, is one of the most beautiful parts of the Milky Way that exists. And of course, it's something that we cannot see at all from here. And this is the region I'm going to spend a lot of the rest of the talk talking about. Centaurus, it's one of the largest constellations in the heavens. And it's actually over here. It almost surrounds. This is Crux, the Southern Cross, Crocus here, and Centaurus is all around here. Now, it's got some interesting objects in it. Well, certainly some. First of all, here's Alpha Centauri, which is a star system, the nearest star system to our own Earth. And of course, an outlier, which we suspect is part of the system, is called Proxima Centauri, 4.2 light years away, the nearest star to our Sun. Here is Beta Centauri, which is obviously a blue giant rather than a red giant type star, or an orange star. I'm going to come back later. It's an interesting star, that one. If, of course, you move over to the right, they act as the pointers. They're called the pointers, and it takes you to the Southern Cross. Now, I have to say, a lot of people that go to southern skies think they've seen the Southern Cross. It's actually not very bright or very big, and quite a few of them have probably seen here. And that's called the False Cross. And that's in Vela, I think. So, if you turn 45 degrees here, you come to that object, which is called Omega Centauri. And it was widely thought to be the biggest and the best globular cluster in our own Milky Way. But now many people suspect, suspect it's actually not a globular cluster, but in fact, the remnants of a small galaxy. The outer stars were stripped off by our own Milky Way's gravitational field. But sorry, before I say that, let's have a look at Alpha and Beta Centauri. There's Alpha, there's Beta. Alpha is the multiple star system. There you are. Alpha A, Centauri B, and Proxima. And you see one is a bit bigger than the Sun, one's a bit smaller, and Proxima is a little red dwarf, which is well away from the two fairly close stars at the center. And I think most people reckon is actually orbiting it, so it's part of the system. Interestingly enough, when astronomers using a telescope in Australia were observing Proxima Centauri, and we know it has in fact a planet called, an exoplanet called Proxima Centauri Beta, or B, they actually picked up with this lovely Parkes telescope in New South Wales some signals that looked a little bit as though they might be from alien people. They were narrowband signals. They were observed over several days. They only observed them when they were looking very close to Proxima Centauri. So could it have been an alien signal? Well, I don't think many people now think so. And in fact, red dwarf stars are not very good for life because they tend to give powerful flares, radio flares, which were not good for life. In fact, a very powerful flare from our sun could worry us quite significantly. Anyway, the fact that they were looking there to detect that emission implies it was a bit of a flare star, and so not very likely to have an intelligent civilization. But I thought it was rather fun. It's the first candidate from a SETI program called Breakthrough Listen, which is funded by a Russian oligarch, and it's using several telescopes. I think, in fact, there's a bit of a system attached to our Lovell telescope just to pick off the signals that we receive and store them for later analysis. So here we are again, same picture. Here's Crookus, the Southern Cross. This is called the coal sack, which is one of the darker regions of dust in the Milky Way. Don't want to do that. And over here, we've got some other lovely objects I'm going to come to shortly. So let's have a look at Crookus first. Oh, sorry, I meant, forgive me, Omega Centauri. There it is. Beautiful object. The first time I really saw the southern sky well was when I'd been to a conference in Cape Town, and we went up to the northern Karoo, where they were just beginning to build their 10-meter SALT telescope. And we were up there, and I just saw Omega Centauri rising as we sort of left there. I had never seen so many stars in my life. I think it's about 5,000 feet up. Total darkness. It was staggering. And in fact, I never went to sleep that night. I just simply watched Omega Centauri as it rose into the higher heavens. Anyway, as I said, we now believe it's actually the remnant or the core of a small galaxy whose outer stars have been stripped off. And there's even some evidence there might be a little 4.6 solar mass black hole at its heart. So it may not be a globular cluster. Also in Centaurus is a rather wonderful object which I wish we could actually observe from Jodrell Bank, but we can't. It's a merger of an elliptical and a spiral galaxy. We call it an active galaxy because there's a lot of things going on in it. And just look at that. Can you see the disruption here in the center? And I think I can zoom in again. This is an image from the Very Large Telescope, or one of these 4 telescopes in Chile. And the Chandra X-ray Observatory has been able to observe a jet. And that's the sort of thing we find when you have a thing called a quasar at the heart of an object. It's basically, we think there's a supermassive black hole and there's a jet coming out of it. That's in fact the 30,000 light year long jet that Chandra has been able to image. This is what we think powers the jet. It obviously doesn't come from the black hole. It comes from the accretion disk of the material infalling towards it. And I'm not fully sure of the mechanism that does it, but somehow you get a lot of particles and a lot of energy ejected along the axis of rotation of the black hole. As the matter accretes in towards the center, it spins faster and faster, and you get friction, and the temperatures go up to millions of degrees, a couple of million degrees close to the black hole. And I'm sure last year, I think it was last year, or was it the year before, you actually saw the image of the shadow of a black hole, supermassive black hole at the heart of M87 in the Virgo cluster. It's quite exciting what astronomy has been doing over the last few years. It really is. And that's a rather lovely composite image in X-ray, in the radio, and also optical. So it's a very interesting object, and lots of people spend a lot of time looking at it and trying to understand how it all works. So in February 2019, I went to Lake Tekapo. I used the 2 telescopes, the camera and the lens I mentioned earlier. And that is a composite of 3 frames using the Zeiss 40mm lens. It's actually a 90 megapixel image. And of course, it's been squashed down here to under 2000. And it doesn't really look all that much better than the one that we had before, but I promise you that it really is. Anyway, there's Crookus, the Southern Cross. And over here, we'll come to those objects shortly. And there, of course, is the coal sack. I'm just zoomed in a bit. Notice there's, on my image, there's something there, and possibly 2 little bright blobs at the top. Well, we'll come to that. How do we know how far away some of these stars are? This actually is quite interesting. And the nearest stars, and those I'm going to talk about, we can measure their distances by what's called parallax. If you have a nearby star and you observe it, say, in April, its position against the background stars will be one thing. 6 months later, when you've actually moved 2 AU approximately in space, it'll appear against a different set of background stars. And from that, we can actually measure from what's called the parallax angle how far away the stars are. So that's the way it's been done. That's the way that the first stellar distance measurements were made. And this is a rather nice little 3-dimensional plot. It shows Alpha and Beta Centauri. Now here's Alpha Centauri. Remember, Proxima was 4.2 light years away. The 2 at the center are 4.39 light years away. But look at this. Beta Centauri is here. It's over 100 times further away. And if it were the same brightness as alpha, it would have to be 100 squared times brighter. It is a very, very bright star. In fact, I think it's one of the fundamentally brightest stars you can see with the unaided eye. If we now look at Crocus, you can actually see that 3 of the stars, Alpha, Beta, and Delta, probably all came from the same little cluster of stars that were formed at the same time. They're all about the same distance away. But Eta, which is a good bit fainter actually, is only 228, and Gamma is in fact even closer, 88 light years away. So it's a nice feeling of what's going on. And there we have, there's Crocus, and you see where the jewel box is and the coal sack below. John Herschel, he was William Herschel's son. He went to the southern hemisphere and he made a lot of charts, and he found many of the objects within it. And he called the southern jewel box, as we call it, a gorgeous piece of fancy jewellery. That was my picture, which isn't very good, of course. It's here, 2 little stars there you might just see, and that's what it really looks like. But again, there and there, I did pick up with my little 40mm lens, 45mm lens. This, on the other hand, is a copper telescope, and it is a lovely thing to see. So that's the southern jewel box. Another picture of it here. The coal sack, as I said, is one of the darkest regions in the Milky Way. It shows up very, very well against a relatively bright part of the Milky Way. Just another picture there, again showing you Crocus, and there's the southern jewel box. Okay, over to the right of Crocus and Centaurus, there was once a very large constellation called Argo Navis, and I think you can obviously do with ships, the Argonauts and Navis Navy. They decided to split it into 2, and the upper half they called Vela, and that the sails, Vales, and the lower part they called the constellation of Carina, and you've heard of careening, and that's to do with the keel. So those are the 2 constellations, and you can see this is actually back to front. There's Centaurus, there's Crocus, and here we have Argo Navis. So there we have them, Vela and Carina. And you can also see that actually in Carina we have one of the brightest stars in the heavens called Canopus. Let's look at Vela first. Rather nice little planetary nebula. It's called the Eggburst one. Obviously we can't image it from here. This is what is left behind at the center. It's about the size of the Earth, very compact, very dense, of course. The current name for these objects, the remnants of these exploding stars, is called white dwarf, but I think that's politically incorrect. I believe the name is going to change to neutral color dimensionally challenged object. And it is a supernova remnant, also in Vela, and you can see it's a little bit like the one we have in Cygnus. And you can actually see the Vela nebula here, all the little bits that have been ejected from the supernova. And this supernova has left a thing called a pulsar. This is about the size of a city like Manchester, I guess, or Edinburgh, something like that, to get nearer to your home. They're spinning very rapidly because as the center of the star, the core has collapsed down, conservation of angular momentum makes it spin up, maybe 50 times a second initially. And there's an enormously powerful field which has been squashed as well. And a mechanism I don't fully understand basically produces beams of mostly radio, but sometimes light, and even X-rays and gamma rays that sweeps around the sky. And I think this little thing hopefully will work. And there we have a sort of simulation. Can you see if the beam happens to point at us once every rotation, and sometimes even twice, you get the 2 beams, we get a pulse. And these things, of course, are called pulsars, and they are very, very good clocks. And they can be used in all sorts of lovely things. And one thing that we're trying to do, the Hubble telescope, along with telescopes across Europe, is to measure the timing of fast neutron stars, some are rotating about 200 times a second, across the galaxy, and to see if we can actually measure any gravitational wave perturbations. We might be able to measure or discover gravitational waves due to the fact that the space is distorted, and hence the time of arrival of pulses at different telescopes might vary a bit. So we are trying. Oh, I have to do that. The velar pulsar, in fact, is a rather lovely one. It's actually oscillating just over 11 hertz. And if you take the radio pulses, which would make a pen recorder sort of blip every time, you apply that to a loudspeaker cone, the cone sort of does a little wiggle, and you get a click. And this is what this one sounds like, hopefully. Rather nice, isn't it? Okay, so that's Vela. And Carina we have here, which is quite a long, narrow one. And you can see some interesting things over here, the Carina Nebula over here, but also Canopus. Let me just say something about Canopus and Sirius, two of the brightest stars in the heavens. A little bit of astrophysics here, which I hope you won't mind. Many of you will know about the Hertzsprung-Russell diagram. And you plot basically the color or temperature of a star across the bottom from the stars over here, which are very cool. We call those red dwarfs over here. And the brightness compared to our sun is 1 up here. So this is in fact a red giant because it's reddish, it's cool, but it's very bright, 100 times brighter perhaps, a red supergiant. Here we have a blue supergiant, and these are blue giants. So that's the basic idea. And those little white dwarfs I mentioned, they're the remnants of stars. Although they're very small, they're very hot, so they still actually are reasonably bright. And they gradually, as they cool, come down here. So here's a more complicated one, but it does show the Sun and Sirius and Canopus. And you can see that Canopus is way up here. It's well over, probably 50,000, anyway, a lot brighter than our Sun. Now that means it must be burning up its energy more quickly, as of course does Sirius to some extent. So what does that tell us? Well, it tells us, in fact, that it can't, in fact, live for very long, because the faster you're actually burning up your energy, the shorter the life you have. And although the brightness is very high, the mass may only be 10, 20 times that of our Sun. So these stars don't live very long. Well, here I mentioned over to the left, we've got the Carina Nebula, which is here. And down here we have the southern Pleiades. They're not a patch, to be honest, on the northern Pleiades. And there are the southern Pleiades. Again, they're actually against quite a rich region of the Milky Way. They don't show up against the dark background as our own northern Pleiades tend to do. But nevertheless, they're there and they're nice. Above them is the Carina Nebula. And you see it's got this big V shape here, and the brightest part is here. I'm going to zoom in, and that's that dark bit, the dark V you saw. Again, the brightest part is over here. And if you go right into the center, you come across what's called a homunculus nebula. It surrounds a star called Eta Carina. Now, those that know a little bit about the nomenclature of stars know that the brighter stars in a galaxy in a constellation tend to be called alpha, beta, gamma, and so on. So this was once thought to be a very bright star. However, in around 1856, I think it was, it disappeared. And it's only now become visible again. And the reason it disappeared was because it ejected a vast cloud of dust. It was unstable. In fact, it's a star that's probably going to be the first star in our heavens that's going to become a supernova or even a hypernova. And that's a bit like what happened to Betelgeuse, not last Christmas, the one before. You may remember it dropped in magnitude by about 1.5 magnitudes. And I think it's now pretty certain it actually ejected a great dust cloud, which actually obscured some of its light. So there is a star there, which is very unstable. Obviously, as the dust clouds expanded outwards, it's got thinner, and so we can now see it again. But at some point, and I have no idea when, that is going to become at least a supernova, if not a hypernova. Some people think that the combined mass, perhaps a pair of orbiting stars at the center, is 100 solar masses. That's going to be very dynamic. Whether it will happen in our lifetimes, I don't know. Well, we also have down there the Magellanic Clouds, and that's the large Magellanic Cloud on the left and the small one on the right. Just beside it here, in fact, is a globular cluster called 47 Tucanae, because this is in the constellation of Tucana. Okay, let's have a look at this. Notice this rather nice little reddish region, H alpha region here. It is, in fact, I think, the largest region of star formation, like the Orion Nebula that we have, that we can actually see in our heavens. So the Magellanic Clouds, they're members of our local group of galaxies. And we're a little outlying group of galaxies of the Virgo supercluster. The Andromeda Galaxy is the largest. We're number 2. M33 in Triangulum is number 3. And the Large Magellanic Cloud is the 4th largest. They may still be orbiting our galaxy. Some people think they're just passing by. Anyway, they're fairly close. They're the closest galaxies to us, essentially. Here's a small magnetic cloud. Not that exciting, except for one thing we'll come to, and there you see 47 Tucani. But that particular little galaxy helped solve a key mystery of the universe: its size and its age. It's a story you probably know, but let me quickly go through it. Galaxies in those days, in the 20s, were called white nebula. They didn't know where they were. They didn't know whether they were within or beyond our Milky Way. And one of the most highly respected astronomers, Harlow Shapley, he was the guy that worked out how big our Milky Way was and how far the sun was from the center. He basically said he'd observed an explosion, a novae, in one of these white nebula, and pointed out if they were very distant, they would have to be impossibly bright. Well, in those days, they didn't know about supernovae. So in fact, that didn't actually say they had to be close by, but that's what people thought. Others thought they might be further away for various reasons. Now, this was the key to it. And again, I think the UK has had a pretty good track record in astronomy. I hope it continues. So 200 years ago, John Goodricke discovered a type of variable star. The star was called Delta Cepheid, and this type of star now called Cephids or Cephids. This star basically is a clock. Its brightness varies regularly with a period of 5 days, 8 hours, 48 minutes. So it's a very regular clock. And that's the sort of thing you see. The star is unstable. It's in the latter stages of its life, and many stars become unstable then. It rises in brightness quite quickly and then falls more slowly, rises and falls, and it has this very regular pattern of brightness. And this is a key thing. I showed you the Hertzsprung-Russell diagram just now. Look where these Cepheid variables are. They're right at the top. They're some of the brightest stars in the heavens, and that means you can see them over very great distances, even in some of the nearer, and actually not so near now with the Hubble telescope, galaxies. So if we could find out how bright they were, we can actually use that to measure distances beyond our own Milky Way. Well, a lovely lady called Henrietta Leavitt, she joined the Harvard Observatory at 30 cents per hour in 1895 as a computer. The director of the observatory had a group of ladies that did the calculations, because they used to do lots of calculations in observatories in those days. He called them computers, and I think that is where the word comes from. So you may have learned something tonight. She did a lot of photometry. She discovered lots of variable stars, but more significantly for us, she observed Cepheid variables in the small Magellanic Cloud. And here it is, and here's us. Now, can you see that all the stars here are pretty much the same distance from us? So if a star here is brighter than another, it really is brighter, give or take a bit. So that's key. She observed these Cepheid variables, obviously not from Harvard, but Harvard had an observatory in Peru, and that's just a picture of it, rather nicely. And here are some light curves, and it's not very obvious from this because they're in magnitudes. But the point is this, that the brighter the Cepheid variable, the longer the period. And that's not too surprising. A bright star is probably bigger. And a big bell has a low tone, and a small bell has a high tone. So probably you should expect that the more massive, the larger stars have got longer periods, the brighter stars. And she produced a plot. It's called the period luminosity relationship. And there's only one thing you need to know about this. It's almost linear plot. Yes, it's logarithmic, sorry. That here, a Cepheid variable with a period of around 30 days is around 10,000 times brighter than our sun. That's all you need to know. But she produced this plot. So if only they could find a Cepheid variable in another galaxy, from this plot, they might be able to work out how bright it was and hence how far away it was. And of course, the guy who did it was Edwin Hubble, observing M31, the Andromeda galaxy. Here it is at the, I suppose, the eyepiece, photographic plate of the 100-inch telescope at Mount Wilson. He basically did a lot to help build the 200-inch at Mount Palomar. They found the light pollution at Mount Wilson was getting too bad, and so they moved further to the east in the mountains. And on the 6th of October, 1923, he realized he'd found a Cepheid variable in Andromeda. I suspect this is probably the most significant photographic image in astronomy of the last century. Well, he was able to measure its period. And the period was, in fact, 31.6 days, I think. And from that, he was able to calculate how far away Andromeda was. He only made it about 860 light years, which is a lot less than the 2,500 we think it is now. And that's, in fact, because there were two types of Cepheid variable. And the ones in Andromeda were not the same as the ones, the same type as the ones in the small magnetic cloud. But that wasn't his problem. It at least showed that these white nebulae were outside, well outside our own Milky Way galaxy. I want to now come down to Lowell Observatory. In fact, that's where Percival Lowell had actually made this wonderful image of Mars with a 24-inch Alvin Clark refractor. And he basically measured the speeds of approach or recession of 14 galaxies by measuring the blue and red shifts in their spectra. In fact, 3 nearby galaxies like Andromeda M33 are approaching us, with the remainder going away. And that's actually the expansion of the universe, as we shall see. And this is what Hubble did. He observed those same galaxies and he plotted their distance along the bottom. So 1, that's a very big distance, and 2 is twice as big, a very big distance. And he plotted those distances against the recession velocities or approach of these 4 galaxies here, nearby ones. That's our own gravitational field, or our local group, making things collapse a little bit. As you know, I think Andromeda is going to coalesce with, I won't say impact, because not many things actually hit each other, coalesce with our own galaxy in about 4,000 million years' time. Anyway, that's a sort of linear plot. And in fact, with later data, it's a very good linear plot. So what does that tell us? Well, it's Hubble's law. He says the velocity is equal to a constant, which is Hubble's constant, times r. There's a naught there, and that actually says it's not a constant. It does actually change with time, slowly. It's the current constant of proportionality. Now, I want to explain what's going on. Here's my own little universe. It's got 3 objects, red, green, and blue. Initially, they're 10 miles apart. I'm going to allow this universe to expand by a factor of 2 in 1 hour, and that gives you the result at the bottom. I hope you can perhaps see the blue one, because I've got pictures of people down on the right-hand side, but perhaps you can see that. Now, look, if you look from here, in that hour, this green object, the green galaxy, whatever it is, has actually moved 10 miles. So its average speed of recession is 10 miles. But the blue one, which was 20 miles away, twice as far away, has actually moved 20 miles. So its average speed of recession is 20 miles an hour. So if you have an expanding universe, more distant objects appear to go away at speeds which are proportional to their distance. The further away they are, the faster they appear to move from you. So Hubble had shown that we live in an expanding universe. And of course, if the universe is getting bigger with time, in the past it must have been getting smaller. At some point, you go back to it have no size, the Big Bang, and hence you can calculate the age of the universe. In fact, he got a value of 2,000 million years. And I said that's not because he was wrong, it's because the Cepheid variables weren't the type that they thought they were. And basically, it was just the data he was given that didn't quite work out. And obviously, it can't be right. The solar system is about 4,500 million years old. Some stars appear to be 12,000 million years old. So what was wrong? Incidentally, there's a star called the Methuselah star, and it was thought from various observations to be actually older than the age of the universe by quite a bit. The latest values actually give it an age at 14.6 billion years old. Now, we think the universe is about 13.8, something like that. But the error bar is sufficient. It could be, in fact, be correct. So I don't think the Methuselah star, look it up on the web, is actually older than our universe. That would be rather difficult. Anyway, as I said, there were two types of Cepheid variables, and the delta ones that had been discovered by Goodrich were not the same as the type 2 ones they were observing in these other galaxies. There's actually a problem with Hubble's constant. Jodrell Bank was heavily involved in what's called the Planck spacecraft, which has made the best observations of the cosmic microwave background to date, and the value it has given is 67.4 plus or minus 0.5 as a value for Hubble's constant. However, people using the Hubble telescope and Cepheid variables get 73.9, and you can see the error bars don't actually cross. There is a group using what's called the red giant branch of stars, and they're getting 69.8, which sort of straddles the two. So I think somewhere we're going to have a value just below 70. Maybe I should say that I'm sure the CMB is right, and that's because we were involved in getting it, but that may not be true. In fact, there was a neutron-neutron star collision observed, a year and a bit ago, 14th of August, I think, not last year, the one before, and that actually was the collision or coalescence of two neutron-neutron stars, and from that, in fact, they have actually managed to get a value of 70.3 plus or minus 5, which is pretty broad error bars, but they reckon if they can detect 50 such collisions, they'll get an accurate value. So that's a way we can perhaps get around to the slight problem. What is the value of Hubble's constant? How old is the universe? I said there's a very nice globular cluster, 47 Tucana, next to it. You see it down here. And that probably is the best one you can see in the southern hemisphere, assuming Omega Centauri is not. And that's just a picture of it there. Okay, this is the Large Magellanic Cloud, which I actually photographed with my little Zeiss lens, and I was quite pleased with that. This here, all right, is as I said, a very large region of star formation. It's called the Tarantula Nebula because in a decent picture you can see these little things here looking like the legs of a spider. It was called 30 Doradus, and again, those that know about star nomenclature know that stars not as bright as those called alpha, beta, delta, gamma, etc., had numbers, and so 30 Doradus was in fact the star. Actually, you move from right to left in right ascension, numbering them. So it's a star in Doradus. Now, in fact, it's actually a group of stars here, a cluster in this Tarantula Nebula. What was very exciting, and sadly we couldn't observe it from Jodrell Bank or where you are as well, was a supernova in 1987. It's called 97A. It was discovered by Ian Shelton. Interesting story. It was photographed by Robert McNaught in Australia, obviously before they could observe it perhaps in Chile, which is where Ian Shelton was. But he decided to process the plate he'd taken the following morning. However, Ian Shelton in Chile processed his plate after he took it, and he was the first person credited with observing the supernova. Now, there is someone who was in the UK who was actually in Namibia at the time, and I think he probably saw it equally early, but there was no way he could let the world know. And I think I spoke to him when I was talking to another astronomers society recently. Anyway, so it wasn't Robert McNaught, it was Ian Shelton. Robert McNaught did, however, his name has become not famous, but better known. There was a wonderful comet which is named after him. We didn't see it very well in the northern hemisphere, but it was very well seen in the southern hemisphere. Now, we're nearly at the end, but interestingly, a burst of neutrinos were observed 3 hours before the light arrived. Why and how? Well, first of all, some physicists, and they'd make up funny theories, reckon that protons, some of them, might decay. And if protons decay, I think the universe would sort of pack up. And you obviously can't look at one proton for 1 billion or 2 billion years, but if you look at 1 billion protons, there's a chance you'll see one decaying. And obviously you get lots of protons in water, H2O, so there are 2 protons in every molecule of water. So they had these big tanks surrounded by photodetectors you see there. And these didn't detect any proton decays, but they did detect a background of neutrinos, because they can also cause little Cherenkov flashes of light when they interact with an atom or molecule, or nucleus, I should say. So there they were, and in fact, 50 billion neutrinos from that actual explosion, supernova, pass through each square centimeter of the Earth's surface. And 24 or so were detected by these detectors in 3 sites across the world. And in fact, because the Cherenkov goes out in a cone, you can actually measure roughly where it's come from, where they've come from, and it was in fact pointing down towards the towards the Magellanic Clouds. Now look, we all have some liquid, water-ish, surrounded by photodetectors, our eyes. It's reckoned that at least 2 people on the Earth would have had a flash of light in their eyes caused by a neutrino interacting with a nucleus in their eye. Wasn't me. The Hubble telescope has taken some wonderful images, and here it is, and this bit blown up. You can see there was a ring. This in fact was a shell that was in fact ejected from the object when it was unstable, before it actually blew up. Now what the Hubble telescope has done is made a sequence of images. Just watch that. Do you see at some point the ring becomes much brighter? I'll let you see that once more because it's rather long. What's going on? Well, the ultraviolet light from the explosion gradually moved out into space, and 200 and something days, we'll find out in a minute, it reached the ring and basically caused it to erect, to give off much light. So there you see that lovely picture when the ring is lit up. Now, it took 232 days for the UV light to reach it. The HST image shows the radius of the ring is 0.86 arc seconds. And I think you can probably see you've got, in fact, 232 light days is a distance. The radius you've got from that, you can actually calculate how far away the supernova is. And that's a pretty good measurement of how far the small Magellanic Cloud, the large Magellanic Cloud is. Sorry, my voice is going. ALMA, which is the large millimeter array, also part of the of ESA, is very high up. And because of that, it can actually work at very short wavelengths. It actually helped make this observation of the black hole shadow in Virgo A. And some nice pictures of it here. They're very solid dishes because you get gales up there. There's the Milky Way. Can you see the coal sack? There's the coal sack and the Southern Cross. And that's the Eta Carinae Nebula. And that's the Southern Pleiades. You see, they are there. Another nice picture there. Anyway, just a couple of weeks ago, a few weeks ago, they produced this image, and they think this is where, in fact, the neutron star, that's a remnant of the supernova, actually lies. So that's rather nice. That's a pretty picture of what they might look like. So finally, my last trip, I went to Lake Tekevo twice because I was going south to the southern part of South Island, then back again. And that evening, I went down to the coast, or the shoreline of the lake. I spent, when it got fully dark, quite an hour or so imaging this picture, which again shows Alpha and Beta Centauri, Coalsack, you'll be bored with this in a minute, Southern Cross, Carinae Nebula, Southern Pleiades, and so on, and that's Canopus. And here, of course, is the large Magellanic Cloud. However, before it got dark, as it was getting dark, I took a picture. If anyone's been to Lake Tekepo, and if you do go to South Island, you'll obviously go there. Little chapel, they call it the Church of the Good Shepherd. And standing about here with my camera, I took a picture of the church just as it was getting light, and then I combined the two together to give me a sort of a sort of an arty picture of the southern sky, and that's actually won me a cup, so I was quite pleased with that. So there we go. It's a lovely place to go. If you're ever allowed back into New Zealand, I would say do go there. And I think South Island has got more to offer than North, but they're both very interesting. I've been writing for about 3 years now, I think, called my Astronomy Digest, and that will find it. Just put Astronomy Digest. It's actually www.ianmorison.net, and notice there's only one R, which is unusual. There aren't many of us. We actually come from the Isle of Lewis, from Stornoway, where my great-grandfather ran the dye works, was the manager of the dye works there. To some chagrin, I discovered only about last year that Donald Trump's mother came from the village of Tongue, which is about 4 kilometers away from my great-grandfather's house. I just hope there wasn't too much interbreeding sometime in the past. Anyway, thank you very much for listening. I hope that was all right. And we've got time, I hope, for some questions. Not a lot, but anyway.
Yep, certainly have you. That was absolutely fantastic. I'm not seeing any questions come in, but I've got one myself, if you don't mind me asking. Is there a limit to the size of lens you can use on those smaller cameras you've got? Yeah.
Oh, good question. No, I've gone up to 500 millimeters, and
Really?
I've actually got a Tamron used to make a very good 500 millimeter mirror lens, f8, and I've got a 2x converter to make it into 1,000 millimeter. Now, obviously, that's a fairly hefty thing, isn't it?
Mm-hmm.
And I use that with a full frame Sony camera, and that particular little nano tracker couldn't cope with that at all. But I do have a couple of other ones, including, in fact, there's a telescope made by Explore Scientific. It's the EOS 100 something, costing about £400. And that actually makes a very, very good star tracker. It doesn't have a hand controller. I run it from a laptop, but you can run it from an iPad or something. And I use that with my larger cameras and telescopes. And that Astro Track will also carry quite a bit.
Right. Rich, have we got any questions at all, do you know?
I've got a few questions. I
thought
thought
you might have. If any of the panelists got questions, please, sort of butt in. And any of the attendees, if you've got questions, just put it into the Q&A now, please.
Yeah, one question, Ian, and thanks actually for an absolutely superb talk. It was really good and lots of information and lots of things we don't see from here. So that was,
that was the aim.
Yeah, well done, mate. Yeah, 10 out of 10, and you hit the bullseye, so to speak. It's yeah. You mentioned very early in the talk that there was an area of New Zealand that's a gold star dark sky site. What's required exactly for that status?
Well, it's got to have very, very few people living there. They've got to take great care about lighting. Any lighting has to be minimal, but also looking down. So there's not much going up into the sky. And most of the ones, there's 4. Namibia's got one. As I said, Kerry's got one. New Zealand's got one. And I think there's now one in Central America. They're largely places where nobody lives. And that's why they're pretty dark. But there's 4 of these gold star ones. If you go on the website of the dark sky people, you'll actually find them. And I think the American one was only added last year. But you've got to be pretty good.
Great. Okay. Yeah. That's that's largely what I thought. But it's interesting because we've got some friends at in Cairngorm trying to establish a dark sky site at the moment, and but they're struggling a bit because of development in their area, but
that's the trouble.
That's right.
Well, I wish them luck. I mean, there are quite a number now in the UK. I had a lovely trip 2 years ago to Sark, where there's no lighting at all at night, and in fact, in the cottage we were staying in, we had to leave a light on because you just couldn't see anything. And the only light there, in fact, comes from the Cherbourg Peninsula, where the French have got their equivalent to, what's it called? Their nuclear processing plant, anyway. And that produces some light, but otherwise it's totally dark there. It's wonderful. So they're actually trying to get dark sky island status. They may have already got it actually, but that's what they're aiming. So I wish you luck for the cairngorms.
Yeah,
Is your
well,
funicular working? Is your funicular going again or not?
no, they're still trying to rebuild it. Apparently, the big problem is that it's the only funicular that goes round a corner, and they didn't realize the stresses that going round a corner put on the anchorage, and that's why
Right.
it's come a little unstuck, I think.
So I shouldn't mention that, but I had a lovely trip up there.
Yeah, well,
it is.
It's a great feature, and let's hope they can get it going again soon.
Okay. Anyway, any more questions?
Well, yeah. Well, one final thing is that you've got. I mean, there were some truly spectacular images there. But what do you think is the most striking area of the southern hemisphere sky? What's the jewel in the crown, so to
Well,
speak?
I regard it as that part of the heavens I thought said that contains Centaurus, Crux, Vela, and Carina. I think that's the most beautiful part. Obviously, you've also got the region which has got the large and small magnetic clouds, which are a little bit away from them. But that's the best bit. I mean, the center of the Milky Way is fine, but they're not. Well, I just like that part where there aren't so many objects and you can actually sort of split them apart a bit. So that's my favorite bit.
Great. Okay.
I was just going to say, Tim's come up with a comment more so than a question. Have you got that, Rich?
Yeah, I just picked it up now. Actually, it's yeah, one from Tim, our president. Great talk. Yes. This is not a question, but the address. Sorry, Ian gave on his last slide. Produce it.
Produce an error message. Say it should be ianmorison.com, and he said that seemed to work.
Yeah, I'm sorry. Did I say .net? No, that's my email. Yes, it's www.ianmorison.com.
Just let everybody know that's fine.
I'm sorry. I should change that.
No, well, thanks for Tim there for checking it out.
Yeah, well done, Tim. I apologize. There are about over 100 articles there, and probably over 200,000 words, and lots of pictures telling you how to do lots of things, and covering quite a lot of telescope types and things that you can do with them. So
great. Well, thanks for that link, and obviously huge reservoir of knowledge here. It's great. Right, okay. I think that's it for questions and comments. So
I must have bamboozled you all.
We'll hand you over to you, Pete. Anyway.
Okay, Ian, once again, thank you very much. A fantastic talk. I'd say it had a great balance between fantastic pictures and also a little bit of science, which wasn't too difficult to follow, which I think that's what you try to do in your talks, isn't it? So we used to do a little section called What's Up Down Under. Well, I used to do it myself actually years back during the summertime, as we show some of the images, from the sort of say southern skies. Maybe it's something we should start doing again. What I want to do is thank you very much for giving up your time for us, coming along again, and we want to give you a little gift. I think you may have one of these already, but
let me put my glasses on. Is that a
it's a crystal tumbler. It's got Sigma written on the front.
Oh, that's lovely.
Okay, I think you had one last time. We got the photographs still on our webpage, but now you got a pair.
Oh,
okay,
thank you so much.
If you can just pop your address to Richard or myself at some point, and we'll get that in the post to you.
Well, that's very kind of you. Wrap it up well. I shall look forward to that.
No problem at all.
The obvious thing to do is to put some whiskey in it. My twin brother was the Director General of the Scotch Whisky Association, but I don't really like whiskey very much. Anyway, not to worry.
It's not in case you don't like whiskey. It means you haven't found the one you like yet.
That's
There's a lot to choose from. Okay, but once again, thank you very, very much, and we will be in touch again soon, hopefully, and maybe we can get you up
I'd
here.
I'd like to stay on and watch all your pictures. But
of course, yes, you can stay on with that. Let's say we do have the gathering after that as well. You're quite welcome to come out. The link for that will go up in the chat. See how you get on. All right, thank you very much again. Okay, then everybody, we'll head towards the break now for 10 minutes. So we'll be back just about around 9 o'clock. In the second half, we will have the members' photographs with Mick, space news with Stuart, a little bit of club news with myself. We normally finish about 9:30. Might be a little bit later, but we'll see how we get on. I will put that link into the chat as well for the Scottish Dark Sky Observatory. 10 minutes gives you just enough time to pop over there and put a few pennies in their coffers. As I say, we'll try and help them out as much as we possibly can. Okay, so from me for now, we'll be back in 10 minutes and We'll see you then.
Cheers.
Evening all, and welcome back to the second half of tonight's meeting. And now it's time to have a look at the members' photos taken over the last month, which have been quite good considering the lack of clear skies that we've been having recently. So the first photo, of course, we had the solar eclipse back on the 10th of June, or partial solar eclipse I should say. And there's a picture sent in by David Robertson. Excellent shot there, David. And Alan Tug, awesome colours in that picture, absolutely fantastic. And another one sent in from Gordon Mackey up in Caithness Group. That's some bit of gear you've got there, Gordon. I had an attempt with the 10 seconds or even less of clouds. I just used my phone and a set of solar eclipse glasses, and I managed to capture it. That was the only shot I got. I took a load, but that was the only one that came out. Noctilucent clouds did make a bit of an appearance a few times when the normal clouds disappeared. There's a few here that I took on the 28th, just after midnight. Yep, almost the whole sky to the north was just completely covered. Great night. And also the same night, 1 AM, Gene Stocks captured this one on her iPhone. That one. And Terry Sherman from Fochabers on the same night. And this one was sent in by a Facebook follower, Elaine Sidney, out in Spey Bay. So the same night, 2:20. Cracking shot that. Some good colour in the sky. And Pete Sherman. Some more noctilucent clouds. And finally, I turned on the 1st of July, just after midnight, and I tried to get noctilucent clouds, but there was nothing happening. And I was on my way back in the house and spotted these two, and I thought, what's that? That must be Jupiter and Saturn. And indeed, managed to get Jupiter and Saturn. First time I've seen them this year, since they disappeared. And there's another shot I took of Jupiter. So you get Ganymede, from left to right, you have Ganymede, Io, Jupiter, Europa, and Callisto. So that's all the photographs for this month. And now we go over to Stuart for the space news. Are you there, Stuart?
Stuart,
yeah, just coming on. There we go. Okay, I see that.
Yep, see that, Stuart.
Yep. Okay. Right. there's obviously a lot of space activity in the news these days, which and social media. So you may have seen a lot of what I'm putting over, and you may have later information. I've got a thing that says start my video, but I don't have a video. Sorry about that, I've got a message right across the screen. So what I've done, I've selected certain items, and not in great detail, but enough, I hope, to give just an idea of what's going on, and also what to watch. Okay. This is the surface of Venus that was revealed by NASA's Magellan radar mapper more than 30 years ago. There's been a lot of activity in recent years on Mars. The interest is now turning to Venus, especially by NASA. And one of the reasons is to try and understand why two planets like Venus and Earth that were so very similar at the outset, or we believe to be so very similar, are so very different now in terms of, after all, the period of time. So on the 2nd of June, and after these 30 years, NASA has approved 2 new missions to study Venus, an orbiter radar mapper and an atmospheric probe. The orbiter, known as Veritas, which stands for Venus Emissivity, Radio Science, INSAR, Topography and Spectroscopy, will map the surface to determine its geological history, following up and expanding on Magellan's radar observations. The atmospheric probe, known as Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, the acronyms get longer and longer, is a descent craft that will plunge into the planet's thick atmosphere with a sophisticated suite of instruments to better understand how the planet evolved and if it ever hosted an ocean. And there's the two. There's Veritas on the left, and the probe, which is a parachute probe, which will go through the atmosphere of Venus. The missions will be cost capped at 500 million each, and they're both expected to launch in the 2028-2030 timeframe. At the same time, on the 10th of June, or the same period, on the 10th of June, after NASA announced on the 2nd of June their 2 new missions to Venus, the European Space Agency announced it would launch a mission called Envision to Venus in the early 2030s. And this is an artist's impression of the Envision. And here's another shot of it. The new mission will not be Europe's first to Venus, as you may remember or not, that the Venus Express spacecraft orbited the planet from 2005 to 2014, studying the planet's thick atmosphere, which is rich in carbon dioxide. Envision will also orbit Venus, but its instruments will be able to get a deeper look at the planet than those on board Venus Express did. The instruments will include a sounder to investigate layers within the planet, spectrometers to analyze gases in Venus' atmosphere and compounds on its surface, a radar instrument to map the planet's surface. Although the project is led by ESA, the radar instrument will come from NASA, and the radio science experiment that will probe the planet's structure and gravity field. Other previous missions to Venus: the Soviet Union, which you may remember some of these, targeted Venus frequently from the 1960s through to the mid-80s with its Venera and Vega programs, notching a variety of exploration milestones along the way, despite a number of launch failures. October 67, Venera 4 became the first probe ever to beam data home from the atmosphere of another planet, finding that Venus' surface is incredibly hot and its air surprisingly thick. 3 years later, Venera 7 performed the first successful soft landing on a planet other than Earth. And in 1982, the Venera 13 lander recorded the first ever audio on the surface of another world. And in the mid-80s, the Vega 1 and 2 missions successfully deployed balloon probes in the thick Venetian atmosphere. The United States mounted some Venus missions during this period as well, though not nearly as many as the Soviet Union. Mariner 2, Mariner 5, and Mariner 10 performed flybys of the planet in 62, 67, and 74. And in 78, NASA launched both the Pioneer Venus Orbiter and Pioneer Venus Multiprobe. And the multiprobe sent 4 instrument-laden entry aircraft into Venus' atmosphere in December of that year. And the orbiter studied Venus from above until 1992. And Japan's Akatsuki orbiter has been doing its own atmospheric investigation since arriving at Venus after some tenacious troubleshooting in December 2015. The Magellan mission came to an end in 1994 when the controllers released it or sent it down into the atmosphere for its destruction. So that's all that's sort of happened around Venus, and it's interesting now that they're setting up some what could be considered major missions again to Venus. But it's something to look out for the future. Blue Origin's first crewed flight. There's been some news activity on this, which you've probably heard just recently. Amazon.com and Blue Origin founder Jeff Bezos will fly on the first crewed flight of the new Shepard suborbital vehicle. The billionaire announced on Instagram on the 7th of June. There's Jeff Bezos. He's going to fly with his brother. And they've done 13 launches with the current vehicle, recovering it each time. So it's been quite a success so far. The New Shepard capsule, and the New Shepard is named, as you probably know, after Alan Shepard, the astronaut of the shuttle time, which operates autonomously and does not need a pilot, will launch from Blue Origin's West Texas facility. The flight is scheduled for the 20th of July, and it's the 52nd anniversary of the Apollo 11 moon landing. And the flight will last approximately 11 minutes. And on the 13th of June, it was announced that with a high bid of $28 million, an unnamed individual has won the chance to join the first crewed flight. They haven't named that individual yet, but he's going to be named later. And on the 1st of July, it was announced that Wally Funk was to be the 4th member of the crew. Wally Funk is a highly qualified aviator flying since 1961. And there's Wally Funk. She was part of a campaign for women to be astronauts she qualified in 1961. All the requirements to be an astronaut, as 13 other people did. And they had a campaign to try and become an astronaut in those days, none of which succeeded it. But Congress and NASA would not accept women to fly. And it wasn't until later on that the first woman went into space. Now, she also applied or paid for a seat on Richard Branson's galactic spacecraft. But because it got so late, Jeff Bezos offered her a free flight with him in Blue Origin's New Shepard. So in fact, there's Jeff Bezos, his brother, Mark, this $28 winner. I think it actually cost him $29 million because he had to pay an extra amount for some special American purchase of it. And this aviator, Wally Funk, will fly on the 20th. Richard Branson announced yesterday that he was now going to launch his flight into space on the 11th of July, I think trying to outdo Jeff Bezos. But I think both flights are very weather dependent, so it depends to see what actually happens. The money, the $28 million, is going into Blue Origin's. What they've got is a future space training, STEM organization, which they're setting up, and the money will go into funding that. So it's interesting to see what's going to happen. So it will obviously be on the news, as you imagine, as it takes place this coming month. This is also an interesting one. On the 13th of June, a Northrop Grumman rocket successfully launched a secretive Space Force satellite for space domain awareness, or detecting artificial objects in orbit, in a rapid response mission for the US military. In 2019, the Air Force had a breakaway of what they called Space Force. And the idea was that Space Force would be looking at a warfare situation in space, whereas the Air Force would be limited to the normal atmosphere type activity. And what they called it was space domain awareness. They set up an organization called Space Safari, which is a military entity, to produce a fast response requirement to launch a missile in space, a satellite, or some object that would be required to detect or remove something that was not required by the Western world or the Americans. The plan is that they'll have a 4-month requirement to build a particular satellite and a 21-day standby for launch. And the mission that took place on the 13th of June was a tactically responsive launch, and it's a demonstration satellite and has been used to figure out ways to shrink the timelines for planning space missions as part of Space Force's push to offer more flexible small launch services called responsive launch. And the satellite this particular one was developed in less than a year, and the launch provider was given the 21 days notice to get ready for flight. And there it has been. It was launched from, the rocket was launched from Stargazer aircraft, and then released from the Pegasus XL rocket. And that's the new Vandenberg Space Force base that has been set up, that it took flight from. NASA's Juno passed Jupiter's moon Ganymede safely at an altitude of 645 miles on the 7th of June. However, a lot of the images that it took were not immediately downloaded, and were downloaded later when it's not actually doing any data gathering, as NASA's typically tasks are downloaded once the satellite is clear and in a quiet mode. Although it was only 25 minutes passing, so there's not going to be a great deal of information to be sent down. It's the first close Ganymede flyby in 20 years. The last such pass of Ganymede was in 2000 by the spacecraft Galileo, which orbited Jupiter and flew by many of its moons between 1995 and 2003. And NASA's Voyager 1 and Voyager 2 probes also observed Ganymede and Jupiter's other large moons during a pair of flybys in 1979. And this Juno's flyby of Ganymede offers a taste of what's to come. The European Space Agency's Jupiter Icy Moons Explorer, or JUICE, which is a mission set for 2022, and the robotic JUICE spacecraft will arrive in orbit around Jupiter in 2029, perform flybys of several of Jupiter's moons, then enter the orbit of Ganymede in 2032. And there's an artist's depiction of the spacecraft observing Ganymede during the flyby on the 7th of June. And some of the pictures they've taken. Now, China's Mars rover, Zhurong, was picked up by the Mars Reconnaissance Orbiter, and that shows it here. And the lower bright spot is the rover, but I've got a better one of the rover, actually. That is the parachute and back shell, the white little dot there with the same one. And that is a picture of the heat shield that was obviously quite bright compared to the rest of the surroundings. But this is the one where it shows the rover to the bottom of the screen. There's the reconnaissance orbiter. The NRO spacecraft have been circling Mars for more than 15 years, studying the planet's geology and climate, looking for future landing sites and relaying communications from surface craft back to Earth, among other tasks. The HiRISE, High Resolution Imaging Science Experiment camera aboard NASA's MRO can resolve features as small as a coffee table. And as well as capturing the images of the Chinese rover, Zhurong, it has also captured images of the following on Mars. There's the NASA's rovers. It captured the Spirit, Opportunity, Curiosity and Perseverance, and the landers, Phoenix and Insight. And this is one of the 24th of February of Perseverance that it picked up. And it landed after its landing. Professor Ian Morison mentioned Hubble. Hubble's got a problem. Its main computer and its backup computer have failed. And on the 13th of June, on the 23rd and 24th, they did some tests. They still haven't solved it. And I was hoping that to find out where they'd got to today, but it's interesting that Ian Morison said that they'd got no further with it. So it's actually not producing any information, data or pictures. It was originally deployed in April 25th, 1990. So it'll be from the Space Shuttle Discovery, but it'll be a pity if that goes out of action. And also SpaceX rocket, this is the third failure of an ISS supply rocket. I thought of putting a video in here, but in fact, all it was a single rocket going up and then all of a sudden ended up with the same picture I got there. So I thought it was just a picture on its own. But shortly after liftoff, it exploded. And Elon Musk said it was a possible high pressure in one of the high level liquid oxygen tanks that caused it to explode. To which he said he'll provide further information after that. Mind you, it happened to be his birthday, his 44th birthday on that day. Whether that had anything to do with it, I don't know. Anyway, that's the last of the events, good and bad, and things to look forward to, especially Jeff Bezos's and Richard Branson's launches. Thank you.
Thank you very much, Stuart. Once again, brilliant. The same with Hubble. It will be a shame it's gone, if it goes, but I think it's now 18 years over its sell-by date or something like that, isn't it? It's done brilliantly, hasn't it? It really has done good. Right, so right. We will move on to the club news. Just a little note there about the pictures. If you want to have a look at them again or look at the other ones in a bit more detail, don't forget they're all on our Flickr page. Link to that is on the home screen. So you can just pop over to there and look at them again. As you know, the BAA have planned to hold their summer meeting in Elgin, planned to hold it in Elgin last year in 2020, which was postponed to this year, obviously postponed again now till next year. Now the dates of that, I think I got the dates wrong. Well, I didn't get the dates wrong. Hazel from the BAA gave me the wrong dates. The actual date for that is going to be next year is Friday the 7th and Saturday the 8th of September. This is the 2-day event that's going to be held at the Moray College UHI. Did any of you manage to catch the BAA summer meeting online on Saturday? Just out of interest, if you did watch it, could you put your hand up for me, please? Just click the hand, raise hands. No, nobody. Okay, that just gives me an inkling of who watched it and who didn't, which is nobody. Okay. Yeah, physical meetings and observing sessions. We're looking closely at when we can possibly restart these again. To say, Kevin's actually in contact with Lambrai, but obviously there's a lot of things we've got to put together first before it can happen. One of the main things is whether the speaker's happy to travel, and also whether you as members are happy to gather as well. And I say we'll keep on top of that and see what we can do, and we'll try and get back indoors as soon as we can. Get back in there. Observing sessions. Hopefully, we can do a little bit more with observing sessions. There's obviously things have relaxed a little bit. As I say, things are sort of relaxed a little bit there with how many people can meet outside. The only thing we would say is that we probably wouldn't be sharing any telescopes or anything like that for the risk of sort of transmitting the COVID virus. Tim did come up with a very, very good idea at the last committee meeting last week, and that's maybe we'll have a sort of binocular evening where we'll go out with the laser pointer and we'll show things that you can see in binoculars, and you all bring your own pair of binoculars. Okay, but say leave that with us, and we'll be in touch with you as soon as we can possibly get that going. Sigma on YouTube, don't forget all our meetings are now on YouTube. As members, you get to see them the last 6 months. And then they go live out to the general public after that, the ones we can send out. All the links for that are in the newsletter. If you haven't got one, or if there's something you want to actually want to watch again and you can't find the link, just let me know and I can always resend you the links. Sigma telescopes, talking about observing and not sharing stuff. What you can do is hire the Sigma telescopes. I've now, as of yesterday, managed to get the refractor up together with a proper eyepiece box, so that's nice and easy to take away with you. Probably if you've never used an equatorial mount before, you might need a little bit of tuition of how to set an equatorial mount up, which is not a problem. We can go through that with you when you pick it up. So we got that telescope, and we've also got the Dobsonian as well, the 6-inch Dobsonian. So you can hire them from the club for £5 a month. Maybe still a bit too bright now, but as Mick said, you can catch Jupiter and you can catch Saturn in the early hours if you don't sleep very well. Mick sent me a message saying Jupiter and Saturn's up. I sent a message back to him saying I'm not. But well done, Mick, for actually getting them the pictures of Jupiter and Saturn. I think it must be the first of the year. But say you can just let us know if you're thinking of hiring the telescope, the telescopes. Just send us an email and we can put you on the list, and once the skies get dark again, we can get them handed over to you. Yeah, don't forget, say don't invite a friend. We're always looking for new members. If you've got any friends, I know Helen gave the link to someone tonight. If you've got any friends that are interested in astronomy, just let them know if they want the link. Send them the link, ask them not to share it with anyone else, and just let me know that you've shared it. You've sent it to a friend, and we know who they are when they arrive in the meeting. So Sigma gatherings happening straight after this. I think Richard's just put the link up in the chat. What you can do when I finished here, just click that link, and it should take you straight over to the Sigma gathering. Everybody is invited. You haven't got to be just a Sigma member. It's just a way to have a sit down and have a chat, and maybe have a little drink together and chew the fat, as they say. Okay. Don't forget, if you've got anything from me, any thoughts, any ideas, just ping me an email or pick up the phone, give me a call. We always say it's your club, not my club, and not our club, and we'll do what we can do to make it the best for you. The next meeting, David Patterson from Dundee Astronomy Society with Astronomy and the Art of Navigation. That should be interesting. So with that, I would like to thank Ian for his wonderful talk, Richard for handling the Q&As, Stuart for Space News, Mick for your doing the members' photos tonight, and for all your good selves from all the club societies and any guests that we have here tonight for coming along. It makes it all worthwhile. It's putting time in to bring this together. And we hope you enjoyed it. And if you did, tell your friends. If you didn't enjoy it, tell nobody. So with that, from now, stay well, stay safe, and we'll see you in a few minutes if you're coming over into the gathering. Okay, take care now. Good night.